When you add data to a set, it stores it in a sorted tree data structure. So if you iterate through the set with the set iterator, you'll get all the objects that were inserted in a sorted order. Let's look at an example. We have a set S which stores strings. We are going to insert the string foo, bar, Waldo, and thud. Next, we iterate over it with the standard way of iterating STL containers. The output is sorted. Note that the set cannot contain duplicates. If we insert foo twice, the output is just one foo. This goes along with the mathematical definition of a set, which cannot have multiple copies of the same element. Set guarantees that a search for an element will take O log n time, so the underlying data structure is a self-balancing tree like a red-black tree. Let's look at an example of finding an element in the set. We use the function find and it returns an iterator. If the iterator is s.end, then the item was not found. Otherwise, the iterator points to the found item. We can also select from a range of values. If we call lower bound with a key, it gives us the iterator that starts with the smallest item equal or greater than the key. We call upper bound, which gives us another iterator. We can iterate between the upper and the lower to get the items in the range. If you don't need the set to be ordered, you can use unordered set. It does not have the upper bound and lower bound ability though. If you want to insert multiple items with the same key, you can use multi-set. If you need to store key and key value data object and retrieve objects using keys, the map container is a better choice, though you can still achieve the same functionality using sets. For example, the class element has an integer key and a string data s. We define the less than operator so that the object comparisons can be made. Then we can insert and iterate the same way we did with string-based set, but use elements key for ordering the objects. However, map is a better option in this case when you have key and data.